This is a video over lesson 2, applications of linear equations. Let's start with the first problem. The first question, when 3/4 of a number is subtracted from 11, the result is 5, and we need to find the missing number. Before I get started too much, can everyone hear me and can everyone see the screen?
Yes.
Okay, thank you. And at any point during the lecture, feel free to stop if you have any questions for me. Okay, the phrase subtracted from, think of just a regular arithmetic problem. If you had like 2 subtracted from 3, then the way you would have to write it to solve it is in reverse order. So you would have to rewrite this as 3 minus 2. We're going to do the same thing to set up our equation. So the 11 goes first, and we'll just let n equal to the number. So we have 3/4 times n, and the result is 5, or equal to 5. Now to get rid of the fraction, just multiply each part of your equation by your denominator. So we'll multiply each part of our equation by 4. When we do that, we get 44. In the middle, the 4's cancel, leaving us with minus 3n equal to 20. At this point, it turns into just a regular linear equation. So we need to subtract 44 from both sides. And that leaves us with negative 3n equal to negative 24. And of course, the last step, divide both sides by negative 3. So our missing number is a positive 8. So whenever you see the phrase subtracted from, you must arrange your equation or the phrase part in reverse order. Any questions about this first problem? Okay, let me copy and paste our second problem and bring it down. All right, next question. John painted his most famous work in his country in 1930 on composition board with perimeter 109.78 inches. If the rectangular painting is 5.84 inches taller than it is wide, find the dimensions of the painting. We are eventually going to use the formula perimeter equal to 2 times the length plus 2 times the width. Now, the only other information we're given besides the perimeter itself is that our painting is 5.84 inches taller than it is wide. Taller means the length. So we can represent length by the letter L. And taller than means it's more than. So it's 5.84 5.84 inches more than the width. Now let's plug in our given information into our perimeter formula. So the perimeter is 109.78. In place of L, plug in our expression W plus 5.84 plus 2W. Now we need to distribute this first two. And when we multiply everything in parentheses by 2, we end up with 2W plus 11.68 plus the other 2W. Before we solve for W, combine the W's on the right side. So that gives us 4W plus 11.68. Now we need to get 4W by itself. So let's subtract 11.68 from both sides. So when we do that, we're left with 98.1 equal to 4W. Last step, divide both sides by 4. And the directions didn't say anything about rounding, so we keep all of our digits. 24.525 inches is the width. Now, we need to find both dimensions, so go back and find the length by using this equation right up here. So where you see a W, plug in 24.525, and we're adding that to 5.84. So the length is 30.365 inches.
Give me a second. I'm moving a little slow.
Oh, you're fine. I am actually recording this and I'll share it in Blackboard later on today, just in case anybody missed something. Did anybody have any questions about this word problem?
Sounds like I'm the only one here.
That's fine. I still, even if I have to, one student or 30, I always stop to make sure y'all okay. And, if you have any questions, just feel free to stop me.
I
Okay, we're going to move on to the next couple of questions. So let me copy and paste them from our notes.
real quick. You said that 30.365 was what?
Oh, I'm sorry. 30.365 is the length of our rectangle.
What? Okay. Okay.
All right, let me screenshot our next word problem. Give me 1 second. I'm sorry for the delay.
That's no problem.
Okay. All right, our next word problem. A hotel manager found that his gross receipts for the day, including a 9% sales tax, were $2,725. Find the amount of sales tax collected. Will let X be what we're looking for, the amount of sales tax collected. Think about when you go to the store and you go to the checkout and the sales tax is added to your original purchase price. So not only sales tax is multiplied by what your total is, think about it. The amount of sales tax is actually added to your total before sales tax. So 9% sales tax can be represented as 0.09 times our purchase price. Now, again, when you go to the store and get ready to check out, the sales tax is going to be added to your expenses. So to set up our equation, we have X plus the amount of sales tax, and that's equal to the gross receipts for the day. Now, that first X is understood to have a 1 in front of it. So we can combine those X's on the left-hand side first. Just like money, $1 plus 9 cents is $1.09, or 1.09x. And the last step, just divide both sides by 1.09. And when you do the division, you end up with exactly $2,500. And that's the amount of sales tax that was collected. Oh, no, it wasn't. My goodness. I just saw my boo-boo here. That is our purchase price before the sales tax was added. So in order to find the amount of sales tax, we have to multiply 2,500 times 0.09. So let's see here, 2,500. I knew that answer did not sound right.
All
Times
good.
0.09. Okay, that's a lot better. $225 was the amount of sales tax collected. Not 2,500.
Right. Wait, good banking.
Yeah, that if somebody was collecting that much sales tax, they should be in jail.
Okay, no.
Any questions about this word problem?
Not yet. No.
Okay, I'll leave this up here while I copy and paste the next word problem.
I take that back. I do got a quick question.
Yes.
Oh, never mind. I see it. I see it. I was trying to figure out how you got the 0.09 multiplying the 2,500, but it's the sales tax. Duh.
Yes, sir.
I'm slow.
You're fine. Never hurts to ask, right?
Yeah, something I should have noticed before I asked.
That's fine. All right, this next question is an investment problem. And we want to, let's see, a mother wants to invest $10,000 for her son's future education. She invests a portion of the money in a CD account, which earns 4%, and the remainder in a savings bond that earns 7%. If the total interest earned after 1 year, is $600, how much money was invested in the CD account? So we are only concerned with how much she invested at 4%. So we got to label each percent interest. Um, let's let X equal to the amount she invested at 4%. Now, if she invested X amount at 4%, then the mother invested the rest of it at 7%. So if you take away the X amount from 10,000, the key phrase there is takeaway. Takeaway means subtraction. So the amount invested at 7% is represented by the expression 10,000 minus X. And all that translates to is, okay, she started out with 10,000. You take away the amount that she already invested at 4%, and then whatever's left over is what she invested at 7%. Now, just like in the sales tax problem, we must change each percent into a decimal. So let's set up our equation. We have 0.04x plus 0.07 times the amount invested at 7%, and that's equal to the total interest, $600. Now you can take out the decimals. I'm going to leave them in. The calculations are pretty simple with them. So we have 0.04x. Now, when you multiply everything in the parentheses by 0.07, 0.07 times 10,000 is 700. And 0.07 times negative x is negative 0.07x, equal to the total interest. On the left side, combine your x's together. So when we do that, we get negative 0.03x, just subtracting, plus 700 equal to 600. Now, at this point, we're just doing our usual steps to solve a linear equation. So we will next step subtract 700 from both sides. And that gives us negative 0.03x equal to negative 100. The last step, divide both sides by negative 0.03. And don't panic when you see what you get in your calculator, from your calculator, excuse me, the directions did not say anything about rounding. So if you wanted to stop at the nearest cent and say our answer is $3,333.33, that would be an acceptable answer.
It ain't sixes.
Sorry?
I was making a joke. I said it's a good thing it wasn't sixes.
Oh, yes.
Somebody's in trouble.
Especially if they're three sixes, that yeah,
Right.
we'll round up.
Or if it's six sixes, they got double trouble.
Yeah. Any questions about this problem?
No, I think I kind of got this one finally. I've been
Okay.
trying to grill this stuff in my head at night. Okay.
Okay, you ready to go over the next couple of problems? Just let me know.
Yeah, whenever you're ready.
Okay. Let's clear our
I kind
board.
of wonder if some of the people got your timing mixed up because when you first told us about it, I thought you said from like 12 to like 1:30.
No, I said 11 to 12:30.
Well, yeah, I got that, but
Yeah.
I'm saying I think the first time I heard you mention anything about the WebEx, that's what I thought you said. I'm just
Oh,
saying, don't be surprised if somebody shows up at 12.
that's
They
fine.
may have heard the same thing I heard. I don't know.
As y'all know, I'm very flexible.
One of my problems I'm having with a lot of these equations isn't necessarily the actual equation written out, but understanding the word problems. How, telling you how to write them.
Exactly.
Like what you're showing there, a chemist wishes to mix a solution. Sometimes I have a hard time understanding which way to write it out.
Good. One thing you can do, I know it sounds cliche, but read a word problem at least several, three, four times and see, kind of pinpoint what is missing that you're looking for. Keywords, like right here, the chemist wants to add some. Well, we don't know what that is.
Right.
How much is it? So guess what? That's what we're looking for. So that's kind of half the battle. Just look for keywords to kind of pinpoint the unknown you're seeking. Because we're mixing stuff together, it's a good idea to create a table. So I'm going to create a table for us. First column is the amount of solutions that we got. The middle column is our given percents. Like the other word problems, we have to change each percent to a decimal. And then the last column is our results. I start with the percents first. So we have 5% or 0.05. We have 11% or 0.11. And we're trying to mix these two together to get the desired 7% solution. So 7% as a decimal is 0.07. Now, we do know how much of the 5% solution she has. That's 8 liters. She wishes to add some 11% acid solution. Well, some is not helping us because it's not giving us an exact amount. But guess what? That is our unknown. Now, if we are mixing these together, mixing is the same thing as adding the two solutions together. So in our corner box here, when we add the two solutions together, that's actually the expression 8 plus x. Now, to get your third column, anytime you're going this direction to get your third column, you're multiplying. So when we multiply 8 times 0.05, that gives us 0.4. X times 0.11 is just 0.11x. And then 0.07 times, in parentheses, 8 plus x. And we're going to use that last column to build our equation. Does the table help a little bit better?
Yeah, yeah, it's been. It actually has been.
Okay. Now let's use our last column to build our equation. We have 0.4 plus the 11% solution, and that's equal to put together our desired mixture at 7%. On the right side, let's distribute that 0.07. And when you multiply each part of your parentheses by 0.07, you end up with 0.56 plus 0.07x. Now we'll bring down the left side. Now at this point, it's up to you what side you want to move everything on. Let me subtract 0.07x from both sides. And because we have to move the 0.04 to the right-hand side, let's subtract 0.4 in the same step. Now, when we combine everything together, when we combine our x's, that gives us now 0.04x. And when we combine our decimals, that would be 0.16.
Are you supposed to divide the 4 from 56?
Not yet. That was just regular subtraction.
Hmm.
Yeah, right here, this is just plain old subtraction.
Oh, the 0 threw me off.
Sorry.
That's okay.
Now, here's where we divide. So we'll divide both sides by 0.04. And whether you use a calculator or figure this out by hand, you should get 4 liters. So let's see. Yeah, we would need 4 liters of the 11% solution to get our desired mixture. Any questions about this problem?
I think I divided something wrong. I had uh yeah, that's where I went wrong. I forgot the point in the 16 when I divided it from the point 0.04.
Oh,
It gave me
okay.
400. I was like, that's not right.
So it was
All right,
just a
yeah.
calculation error, not necessarily
Yeah, no, I forgot to put the point on the 16.
okay.
That's my bad.
Let's see. Let me copy and paste our next question. Oop.
Take your time. Glad other people seem to be getting this better than me, evidently. I need all the help I can get. I just hate that I missed the last two classes.
I've had I've had a few questions that students have sent to me privately about this particular section. So it's not just you, it's there's quite a few other students who are struggling.
This question here is one that I'm still stuck on, to be honest. The nuts
Okay.
sounds so wrong, but
We're going to go ahead and draw a table because we are mixing stuff together again. We have the amounts, we have the dollar values in the middle column, and we have our results. So I'm going to put the dollar amounts first. And I'm going to let you take a look at this and see if we can figure out the left column. I will be back in just a second, okay?
no problem.
Okay, I'm back. Randall wants to mix 65 pounds of nuts for $3 per pound with some nuts worth $10 per pound to make a mixture worth $9 per pound. And how many pounds of the $10 nuts must he use? Again, because you are mixing stuff together, it could be chemicals, it could be money, it could be you're finding total admission, ticket prices, what have you. Use or build a table. Now, I've already filled out the middle column, the dollar amounts.
All right.
So let's go back and fill in the amount that we have at each denomination. The 65 is with the $3.
Uh,
There's that keyword again, sum, which is not telling us the exact amount, is it?
no.
So we don't know the amount at $10, so that's our X. Now we're mixing these together to get a mixture worth $9 per pound. So mixing means adding the two amounts together. So our last box here in the lower left-hand corner is 65 plus X. Now, just like we did with the chemistry problem, going across the table this way means you multiply. So when we multiply 65 times 3, we get 195. 10x is just 10x. And then the last box in the lower right-hand corner would be 9 times, in parentheses, 65 plus x.
Okay.
Now, before we use the last column to build our equation, are you okay with the table?
Yeah.
Table really makes a difference, don't it?
Yeah, it does. Sometimes though, I get a little confused. Though I think I just get frustrated. I shut down. I start getting confused and you know flabbergasted.
If that happens again, just skip over to a problem that you know how to do.
Yeah, I've done that. What's happened was a couple of times I switched over to another program and had the same problem. Just I couldn't understand it. But then I would leave completely and go do something else for a while, then come back and it seemed like I'd spend more time at it and finally start to get it.
You can always do two other things. You can use the view an example under need more help, I think it's called.
Yeah, I started doing that more.
Has it helped?
Yeah,
You can
on most things.
also,
I think there was one or two problems I still had trouble with, like the
uh-huh.
angles. Uh, it was an angle thing, and I did everything it showed to do and all, and it still said I was wrong. I couldn't figure out what I was look. I think I must have looked everything over about 6 times. Couldn't figure it out. I ended up going to bed.
I think there's a angle question. There are a couple of angle questions, yeah, we'll go over later in this video. Um, Other thing you can use also under need more help is called Ask My Instructor.
Yeah, I just hadn't got that far yet because that's what I say. Most of them, I could leave and come back, and then I'd be kind of more refreshed and be able to pick up on it.
Uh-huh.
But angle one was late last night. I just went to bed. I knew I was gonna see you this morning on this. I figured I'd ask you then.
Okay.
So I'm trying to catch up. I was kind of running behind. I'm trying to get caught up on all my lessons.
Okay.
So
Let's see. While we were talking, I went ahead and built our equation from the third column. The
yes.
only thing we have to do to start off is distribute that 9. So when you multiply 9 times 65, that gives us 585. And then 9 times x is positive 9x. And at this point, we're going to move our letters and numbers around. When I subtract 9x from both sides, we can also subtract 195 from both sides. So yeah, y'all can combine steps when you're moving terms around. So what's left is, well, 10 minus 9x is 1x, or just plain old x, equal to 390 pounds. So Randall would need 390 pounds of nuts at $10 per pound to get his desired mixture. That's a lot, isn't it? I guess
One
he's
nutty,
throwing, could be throwing a big party. You never know.
yeah, it's one nutty dude.
Uh, but it makes sense because the other amount was 65, which is abnormally large as well.
Right.
Any questions about this problem?
Not now. Pretty
Okay.
much fix that one. Like I said, sometimes with these word problems, just trying to understand how to write it out. It's like I know what it's showing me, but when I read it, I get confused sometimes. That's one of the
So,
learning problems with the learning curve I have.
so you're saying the actual solving the equation is not the hard part, it's trying to get the equation set up.
Right, it's the comprehending of what it's telling me.
Gotcha.
Once I got it, figured out what the equation actually looks like, I can write it out and work it. That's not a problem. It's
Yes,
just trying
sir.
to understand how to write it out as
Yes,
to
sir.
what formula. Because I know with algebra, there's like hundreds of different formulas.
That's very true. For this section, you'll be using actually just two formulas. The perimeter formula for a rectangle that we did earlier in the lecture,
Right.
and then there's one coming up where we'll be using a distance formula. And I'll go over
The,
that particular formula with you. It's actually the next problem coming up.
yeah, it's like the R equals B equals RT, something like that.
Yes, sir. Yeah,
Yeah, I
I'll
was
go
working
over
on that.
how to set that up with you.
Okay.
This word problem involves coins. A man has a box of coins that he uses when playing poker with friends. The box currently contains 48 coins, consisting of pennies, dimes, and quarters. The number of pennies is equal to the number of dimes, and the total value is $3.42. How many of each denomination of coins does he have? You can also draw a table to help you figure out what's going on. So let's see here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then 1, 2, 3, 4. Okay. So we have a penny. We have the dime. And we have the quarter. And let's see. Amount. Uh, my middle column will be the actual denomination of each coin. And then our last column is our results. We'll let x equal to, well, let's go back up here for a minute. It says the number of pennies is equal to the number of dimes. So if we let x equal to the number of pennies, then x is also equal to the number of dimes since they're the same amount. Now, if we add those two x's together, x plus x is 2x. Now, to find the number of quarters, we start out with 48, and we need to take away the amount of the number of pennies and dimes. So the number of pennies and dimes total is 2x. So remember, takeaway means what operation?
Subtract.
Right. So if we take away the number of pennies and dimes from the original 48, we get the expression we need for the amount of quarters. So the number of quarters is represented by the algebraic expression 48 minus 2x.
All right.
Now, the middle column is the denomination of each coin. So no pennies are worth 1 cent or 0.01. Dimes are 10 cents or 0.10 as a decimal. And quarters are 25 cents or 0.25. Now, to get the last column, we go across our table and multiply our cells together. So 0.01 times x is just 0.01x. With the dimes, 0.10 times x is just 0.10x. And the quarter will have 0.25 times in parentheses 48 minus, and sorry it's cramped, 48 minus 2x. Any questions about the actual table?
No, I actually got that.
Okay, very good. Now we're going to use the third column again to build our equation. So we have 0.01x plus 0.10x. Oh, and I almost made a mistake. We don't put equal to because we are adding all the coins together. So we have our pennies, our dimes, plus our quarters. And that's equal to the total value of our coins, $3.42. You can take out the decimal points. I'm just going to leave them in. The calculations are pretty simple either way you go. We can go ahead and combine our x's here. So when we add those two decimal amounts, we get 0.11 x. And when we distribute the 0.25 times everything, that gives us 12 minus 0.5x equal to $3.42.
Okay, I'm trying to let's see. The 1x plus 10x, that's the 11x, right?
Yes, sir.
And then the that's because I took the decimals on this one. That threw me off.
You'll actually get the same answer without the decimal points.
Right. It just added the zeros on.
Yes, sir.
All right. I got you.
Now, let's combine these x's together. So that would give us let's see, I'm trying to figure out what I did here. 111. Yeah, did I miss a step? Let's see, point 11. I'm looking at my notes and I'm trying to figure out how did I get negative 0.39
I don't
x?
know.
Okay, that's
We
got to be a mistake. So let's see here. Oh, no, it's not a mistake. I am right. This is like saying if you have this point 0.5 here is the same thing as 50 cents.
right.
0.50x. So 0.11 minus 0.50. Okay, that's where I got the negative 0.39.
Sometimes that zero makes a difference, I guess.
It sure does, and with me leaving it off, it threw me off.
Yeah.
Now let's subtract 12 from both sides. And you'll get negative 0.39x equal to negative 8.58, or 858 if you took away the decimal points.
Right.
Now let's divide both sides by negative 0.39. And strange enough, these two numbers divide evenly into each other. You get 22. Now let's go back up here because we have to find how many of each denomination we got. So x is both, since pennies and dimes were equal amount, well, we have 22 pennies and also 22 dimes. Now you don't have to plug in x right here to get the number of quarters. All you gotta do is just simple subtraction. If the pennies and dimes, those are 44 coins right there. And we need 48 total. So the number of quarters is actually what's left, or just 4. Any
So,
questions? Oh, go ahead. I'm sorry.
oh no, just so that was 4 quarters, 22 pennies, 22 dimes.
Yes, sir.
Okay,
Now, if you add them up, we got 48.
right. I got it.
Okay. The next two problems is where we get into geometry and angles.
Yeah,
Yay, fun stuff, huh?
all right.
Oops, hold on just a second. There we go.
You good.
Uh, oh, I'm sorry, I'm skipping the distance and rate problem. Let me do that
Wow,
next.
we're not down yet, so you're good. Oh.
Okay. All right, two steamers leave a port on a river at the same time, traveling in opposite directions. Each is traveling 32 miles per hour. How long will it take for them to be 192 miles apart? Again, draw yourself a table. 1, 2, 3, 4, 2, 3. 1, 2, 3. 1, 2, 3. And ST is just short for steamers. So we got the first steamer and our second steamer. As you mentioned earlier, we're using this famous formula: rate times time equals to distance. Now, the second column, the rate, they have the same rate, even though they're traveling in opposite directions. So each steamer has a rate of 32 miles per hour. We don't know the time, so we can represent that by the letter T. We do know the distance is given, and I'll just put this in both boxes because it concerns both steamers. Our
Right.
total distance is 192 miles. Now, if they're traveling at the same time, that means they're traveling together. And together is the same as mixing or combining, means addition. So the first steamer plus the second steamer equals to 192 miles. Simple equation, we just combine our t's together and solve for t. Last step, divide both sides by 64, and we get t equal to 3 hours. So it would take both steamers 3 hours to be exactly 192 miles apart.
Right. There was one that broke it down further somehow because it was saying like I saw one where it was talking about that they had to be 192 miles apart, but they actually traveled like I think it was like 96 miles in each direction.
Uh-huh.
One went one way and one went the other way. I don't know. I'm not sure if you're familiar with the question I'm talking about. It was in the lessons.
It might be the same setup. Send it to me, please, through Ask My Instructor, and I'll be glad to take a look at it and help you.
Oh, I got it. I figured it out. I was just saying that I seen where one had broke down further, but I
Oh,
managed to figure it out.
okay. Yeah, if I'm understanding correctly, it should be kind of the same setup.
It was.
All right, now let's get to the angle problems. All right, we're given this triangle with angles A, B, and C respectively, and we need to find the measure of each angle. One thing, if nothing else, one thing we do know about triangles is that the sum of all three angles equal 180 degrees.
Right.
So we're going to use that fact to help us build our equation. Now, this is in no particular order. I'm just going alphabetically around the triangle. So we're adding all of our angles together. So we have angle A, and before we write down angle B, we have a fraction, 1/4.
Right.
That 1/4 is a terminating decimal, 0.25. So let's use that instead. It will make our calculations a little simpler.
I got this is where I was having the problem. I got the 25, but the
Mm-hmm.
one that threw me off was a half instead of a quarter, and I did it the same way with 5.50, but I don't. That's the one that it kept saying I was wrong. I was doing everything exactly the way you were showing us, but it kept saying I was wrong. I couldn't figure what I was doing wrong.
Could you send that one to me and I can take a look at it?
Yeah, that one I'll try. I should be able to pull it back up.
Okay. Yeah, just go back to that question and go to Ask My Instructor, and
Okay.
I get a direct link to the actual question so I can see it.
Okay.
Now we can immediately combine our x's. This is understood to be 1. So really using money, $1 plus $2 is $3, and $3 plus a quarter is $3.25. Now, when you combine all of your integers, you get -80. Now, to finish solving this equation, add 80 to both sides. Leaving us with 3.25x equal to 260. And we'll divide both sides by 3.25. And when you do that, you get x equal to 80. Now, 80 is not our final answer, though. We have
Right.
to find the measure of each angle. So we just go here, and everywhere we see an x, plug in our 80. So angle A is 80 minus 42. That is 38 degrees exactly. Angle B, we can use the 1/4 again. 1/4 times 80 plus 21. Now, the reason why I used the fraction, I might have said angle by mistake, but the reason why we can use 1/4 again is because 4 can go into 80 20 times, and then 20 plus 21 gives you 41 degrees. And last angle, in place of x, plug in 80 again. So 160 minus 59 gives us 101 degrees for the last angle. Now, if your fraction had been 1/3 instead of 1/4, or a fraction that's a terminating decimal, you would leave 1/3 as a fraction and just work it out that way. Because 1/3, is a repeating decimal,
Right.
and that would your answers would be off slightly.
Yeah, the one it gave me was a half, and I did everything like what you're showing, and I don't know. I just couldn't figure out what I was doing wrong.
I'll take a look at it when you send it to me later,
I will.
and
I'll see you in just a little while after we get off.
okay, so I'll be on the lookout for it.
All right.
Any questions about this angle problem?
Not this one. Nah, I pretty much got this one down.
Okay, let's look at the next angle problem. All right. Shown in the picture, two angles whose sum is 180 degrees are supplementary angles. In other words, they form a straight line. Find the measure of each supplementary angle shown in the picture. Sum means addition, so we're going to add our two angles together. So we have 11x plus 4 plus 8x plus 5. And because they are supplementary angles, they equal 180 degrees. So just like that, we got our equations set up ready to solve. On the left side, combine all of your like terms. So that would be 19x plus 9 equal to 180. Then subtract 9 from both sides. So we have left 19x equal to 171. And then last step, divide both sides by 19. Again, be careful, 9 is not your final answer. We need to take 9 and plug it into each angle measurement. So our first angle is 11 times 9 plus 4. That's 99 plus 4, or 103 degrees. And to find the other angle, you do the same substitution. Replace x with 9. That gives us 72 plus 5, or 77 degrees for the other angle.
Right.
And that's
Yeah,
it.
that I actually understand pretty easily.
Okay.
Surprisingly.
Not surprising to me because you are, as others in my class, you put in the work, and once you get something, you got it.
I just hope I retain it. That's my problem.
You will. A lot of practice will help you retain stuff.
You're right about that.
All right, let's move on to the next few questions. The next few questions involve consecutive numbers. And I think the first one is an age problem.
I don't think I've even got this part yet.
Let's see here. I'm just copying and pasting it to our whiteboard. All right.
Can you
If
can,
Go ahead.
I'm sorry, I gotta use the bathroom real quick.
Okay, well, I'm gonna keep on.
Yeah, sure. I'll be right back.
Okay, I'm just gonna read the problem.
Okay.
If Fred adds his current age to the age he will be next year on this date, the sum is 125 years. How old will Fred be 4 years from today? So we'll let x equal to Fred's current age. And to the age he will be next year. So his age next year, he'll be 1 year older. So you just add 1 year to his current age, x, to represent next year. By the way, these are called x and x plus 1. These are called consecutive integers.
I'm back.
Now, let's see. If we let x equal to Fred's current age, And we're also given the age he will be next year on this same date. So at this time next year, he'll be 1 year older. So that's where the +1 came from to represent the next year. We just took Fred's current age, X, and added 1 to it to get his age, how old he'll be next year. Now, the sum of his ages will be 125 years. So current age plus age he'll be next year is equal to 125. Now we got to combine our x's on the left side. So that would give us 2x plus 1 equal to 125. And as we know, the next step is subtract 1 from both sides. That leaves us with 2x equal to 124. And the last step, divide both sides by 2. Now be careful, this is not the final answer. This is Fred's current age. He's currently 62 years old. But look at the question up here. It's looking for how old will Fred be 4 years from today? So
So if he's
guess
currently
what?
60, he'd be 68 or 66. My bad. Dang.
There you go. So 4 years from now, he'll be 66 years old.
Right.
And again, this notation here is known as, and I'll just write it off to the side here. It's known as consecutive integers. Consecutive integers are positive integers that go one after the other, like 1, 2, 3, and 4, for example.
Right.
Any questions about this age problem?
Not yet.
Okay. The last two problems also involve consecutive integers, but different kind of integers like evens and odds. So I'm going to show you how to set those up as well. Okay, let me screenshot the next question. And we'll see what it's talking about. Find 3 consecutive even integers such that the sum of the least integer and the middle integer is 20 more than the greatest integer. And when I first read this problem, I'm like, what do we do?
Right.
As I'm sure y'all were thinking the same thing too when you saw this in the homework. Start with some tangible numbers. Consecutive even integers means 2, 4, 6, and so forth. Now, if we let x equal to 2, which is the least integer, what would you have to add to 2 to get 4?
2.
So we're adding 2 to x also to get the next expression. So that's our middle integer, x plus 2. What did you do to 4 to get 6?
2.
2 again. So when we add 2 to this 2 already here, we get the expression x plus 4. And that is our largest or greatest integer. Now, let's go back and read what we're supposed to do. The sum of the least integer, so that's x, and our middle integer, that's represented by x plus 2, is 20 more than the greatest integer. So the greatest integer is x plus 4, and we're adding 20 more to that amount. We got our equation set up. Now let's combine like terms and like numbers. So over here, we combine our x's to get 2x. And over here, when we combine our numbers, we get 24, positive 24, I'm sorry. This x is understood to be a 1. Now, we know at this stage in the problem, pick a side to move your letters and your numbers. I'm going to subtract 1x from both sides. And in the same step, let's subtract that 2 from both sides. So 2x minus 1x just gives us plain old x equal to 22. All right, so the directions said find all 3 consecutive even integers. So our answers are 22. Sorry, my next door neighbor just sped off in his motorcycle, if you heard that
Oh, I
noise.
ain't hear nothing.
22. Then the next consecutive one after that is 24. And then the last one or greatest one would be 26. Any questions about consecutive even integers?
Can't think of any. I mean, so far it was pretty straight.
The next question deals with consecutive odd integers. And I'm going to explain to you why we can use these same 3 notations.
What did you call the last one we just did? That was consecutive even integers?
Yes, sir.
Okay. I'm just labeling my notes to help me remember.
Okay. Yes, sir. That was consecutive even integers. All right, let's look at the last question on our notes.
Right. This one's the uneven.
This one's a little different. Find 3 consecutive odd integers such that the sum of the least integer and the middle integer is 9 more than the greatest integer. It sounds like the last question, and it's true the setup is going to be similar. When you think of 3 consecutive odd integers, you think of things like 1, 3, and 5. So let's let 1 be our x, or our least integer. I'm just abbreviating Li for short. Well, what did you add to 1 in order to get 3?
2.
Right, so when we add 2 to x, we get the next expression in our integers, x plus 2. So x plus 2 is our middle integer. Same question as before. What did you add to 3 to get 5?
2.
2 again. So when we add 2 to x plus 2, we get our greatest integer, x plus 4. So that's what I was talking about earlier. You can use the same expressions to represent consecutive odd integers. Now, let's build our equation, see what we need to do. The least integer, sum of the least integer and the middle integer, so that would be x plus 2 is 9 more than the greatest integer. So 9 more is plus 9, and our greatest integer is x plus 4. So all we got to do now is solve our equation. On the left side and right side, combine like terms. So when we combine the x's, we get 2x and then plus 2. And when we combine the integers on the right-hand side, we get x plus 13. Now, at this point, it's up to you. Pick a side. I usually put my letters on the left side. So I'm going to subtract 1x from both sides. And in the same breath, we can subtract 2 from each side. So we're left with x equal to positive 11. Well, that is our least integer, but we need to find the other two integers.
13 and 15.
There you go. That's correct. Before we sign off, we finished about right on time. Did you have any questions about anything today?
I think we covered them. Yeah, because I was having trouble between the angles and the nuts.
Okay.
Like I was saying, one of my problems now with the angles, that one I'm gonna send you that problem because I